Okay, and also for those of you who have finished, I haven't told, you guys are the only class that I've told that I'm having a baby yet. And I'm like kind of nervous to tell the other kids because I like don't really know them that well. It feels weird.
You shouldn't just disappear. Just vanish.
Thing, and then just disappear in February. Yeah, if we were in school, like you can tell. I would not be able to hide it. Everybody would know. But with this online thing, I can hide it pretty well. Nobody knows. Okay, about 1 more minute, and then we'll go ahead and do the warm-up for today. Okay, let's go ahead and get started. Do you guys need, hold on, I'm going to check the document camera. I should have been doing this. Do you guys need the, I'll have it up. Here we go. Have it go away. Goes down here. That go away. You guys' cups. My daughter keeps mixing up all the names. She like takes people's names out of one and puts them in another one. You noticed the other day. Okay. Reorganize everything. Okay, so this is pretty bright. Make it a little darker. How did that make it worse? There we go. Okay, so we have the function f is given by f of x equals sine of x squared cosine x. Find the area of the shaded region. Okay, so Douglas, what should I do first? Hold on, somebody's trying to get in. Hey, Osvaldo. Okay, so Douglas, what should we do first to solve this problem?
Do you set up an integral?
Yeah, we need to set up an integral. What's going to be in my integrand? The stuff on the inside.
The equation, sine x squared cosine x.
Perfect. And what are we integrating with respect to which variable?
X.
Yeah, so we need to have our dx at the end. And what are my limits of integration going to be?
0 to b.
Yeah, so we need to figure out what b is. All right, so thanks for setting that up. And Izzy, can you tell me how we're going to find b?
I have no idea.
Okay. So where is b located on this graph? Like what's special about that point?
It's on the x-axis.
Exactly. So what's its y value?
0.
Yes. So we're going to set 0 equal to the function. Okay, and we're going to try to find the places, the values of x for which the function is 0. Okay, so we could either find where sine squared x is 0, which is really just where sine x is 0, or we can find when cosine is 0. Either of those will give us a product that is 0. Okay, so when is sine 0, Izzy?
What sign is that? Wait.
Sine is the y value. So on our unit circle, when is my y value 0?
At 0 and at 2 pi.
Yeah, 0, pi, and 2 pi. Okay. And Megan is in her meeting. Sionica, when is cosine 0?
pi over 2 and 3 pi over 2.
Perfect. Thank you. Okay, so we kind of have a lot of possibilities here. So we need to rule out some of them. Olivia, can you help me rule out something?
Well, we already have 0.
Yeah, we know it's not.
So
Now, what about the
I-
answers? How do I figure out which one of those it is?
not sure.
Okay, so let's like look at the graph of our function. So our function goes kind of like this, right? At every single one of these x values, we will have a point where this function crosses the x-axis. Oops, you can't see what I'm writing. Okay, so at every single one of these points, this function should cross the x-axis at those points. We've accounted for 0. If that is the case, then these should just be in order. So this should be the next smallest x value, okay? Because all the other ones are just farther along the graph. So what should this be? Which one of these is the smallest?
Pi over 2?
Yeah, perfect. This must be pi over 2. What questions does anybody have about that, about why we chose pi over 2? Okay, so all of that was to find b, okay? Now we need to go back up here and we need to stick it in there. So 0, pi over 2, sine x squared, cosine x dx. And now we've actually got to do the integrating part, okay? Okay, so Kana, are you here?
Yes.
All right, so can you help me actually integrate this? What method am I going to use?
I'm
I'll
not
give you a hint.
sure.
So we have a specific type of function right here. It's specifically a composite function where we have one function inside of another.
I'm having trouble remembering which one.
That's okay. So when we have a composite function in our integrand, we need to use u substitution because we have something inside of another function. So what function is going to be our u?
Is it sine of x?
Yeah. Okay, and what is du?
The derivative of sine is cosine of x.
Okay, so our du is just cosine x dx. So this is super nice because I can replace all of this with du, right?
Mm-hmm.
And then I can replace my sine x with u, and I get the entire thing in terms of u. So now my function should look like 0, pi over 2, u squared du. Okay, so K-Not, can you tell me how to integrate u squared?
Would it be like 1/2?
Not 1/2, because the power is going to go up.
Oh. So it would be. Wait, it wouldn't be like 1/2 u to the.
What's my new power going to be when I integrate? I add 1, right?
So it would be 3.
Yeah, so now my coefficient needs to be what times 3 gives me 1?
1/3.
Okay. So now we've integrated, and I need to stick my, and we're going from 0 to pi over 2. I need to stick my u back in so that I can use these limits, okay? Because technically right now, these limits don't really match the integrand because we've changed the integrand. So now we need to stick our u back in before we actually do anything. And 0 to pi over 2. Okay, what
Doesn't
question?
it supposed to be 1/3?
Oh, I'm sorry. Yeah, it does need to be 1/3. I just wasn't thinking for a second. What questions do you guys have so far about what we've done? Is everybody following? Okay, now we need to actually like find the numerical value of this. Megan's still not here, I don't think. Taylor, can you tell me what to do now?
You can set up the equation. So it's going to be 1/3 sine. Would it be pi over 2 first?
Yeah.
Cubed minus 1/3 sine 0 cubed.
Perfect. Okay, sine of pi over 2, Taylor. Taylor, what's sine of pi over 2?
Isn't it? Hold on.
Look at this circle up here. Pi over 2 is up here. What's the y value of that point?
Wouldn't it be 1?
Yeah, good.
Yeah, okay.
So just 1/3, 1, 2, and then sine of 0 is what?
0.
Yeah, make that 0. Okay, so my final answer is just going to be 1/3. And you're done. And I guess we should have units squared. Stick our units in there. All right, so that is the whole warm up. What questions do you guys have?
I thought it was sine of 0 and not just 0. I'm a bit
Right, but sine of 0 is 0, and
Oh,
0.
wait.
Okay. Any other questions? All righty, we're gonna go ahead and get started with notes then. Let me double check and make sure this is recording because now I'm second guessing whether or not it is. It is recording. Okay, so I'm gonna enlarge this. Get this little ladybug out of the way. All right, and we're gonna start with the box and whisker plot notes. So if you printed them out, go ahead and grab those. If not, these are pretty easy to just follow along with, so no worries. But we're starting here, okay? So this, it's pretty easy. You should be able to just follow along. All right, everybody good to go? I'm gonna assume yes. Okay, so we can get a sense of a data set's distribution by looking at what is called the 5-number summary. The 5 numbers in the 5-number summary are going to be a minimum, first quartile, median, third quartile, and maximum. Okay, so the minimum, obviously, is the smallest data point. Hopefully that was obvious. I guess I'm writing it down, so maybe for some people it might not be. Okay, the first quartile, it's also called the lower quartile or Q1. Okay. It's the cutoff for the lowest 25% of data.